what I want to present today is a still ongoing work, in the sense that, of course, is not finished. I mean, research is a continuous process. I will show you some ideas, some results of what we are trying to do. Why I think this is important? Because it's a serious attempt to put together two worlds that are the universe of software engineering and the universe of data science that definitely must cooperate, but not always inside the organization is easy to put these people together, because sometimes they start from different premises and also different interests. But I think it's absolutely unavoidable, especially you will see in the context that is the context of DevOps that I'm going to present you right now. On the other side, now I will also at the end of the talk briefly present some ideas, because now the world is becoming very interesting. Because with the data science and also with software development, with the kind of systems that we have, we are able basically to collect so much information about a domain that we can completely master it if we have sufficient computational resources. So we can know more about the people of what they know themselves about them, and more about the developers of what the developers actually programming style and working style, so we can know them better than themselves. So this is very interesting. We are going to show a little bit of what is possible to do. And this has to do with anomaly detection, which is something very well known. There is a lot of literature we will see also in data science, in machine learning about anomaly detection. We try to apply anomaly detection in a kind of little bit newer context, okay? That is the context of the continuous releases in the software environment, in the DevOps environment. We want to continue this work. This is why maybe occasions like this one are good for getting new cooperation, to get new people interested in this kind of research, both on the software engineering or data science, artificial intelligence, or maybe even other research domain where maybe new ideas can be brought in. So far, I think this work started by few people. Some of these people are in Innopolis, and some of these people are in Italy, University of Messina. In particular, the last two cooperators are my Italian colleagues, those that together with Luis mostly mastered the data analysis, where I'm kind of weaker. So we want, of course, to expand this team. Eventually, we want also to apply for some funded project for this kind of research. So, but I have to thank them also for the work to be possible. Our portfolio of expertise, if you consider all the team, is pretty broad, because we are software engineers. We know about software processes. We know about software quality. I can also add software architecture. So whoever here maybe in this specific talk is less relevant, about software process like DevOps, and especially data science and machine learning is what my colleagues brought in. A little introduction. So what are the current trends in the software development? So this is very interesting, no? Because we usually think of progress as something that has to do with producing a new device, a new technology, a new telephone. But technology is always also the process. So you see that we have a global process of automation. Automation to the point that maybe in 10 or 15 years, many professions, and this can be related also with the pay scale usually, you tend to say that lower paid job will be replaced first. I mean, this is what we tend to believe. It's probably true. But at some point, even professions like teachers or other more intellectual jobs, but in a more limited manner, can also be replaced. And this is a global process. This is happening. It's not stoppable. The inertia is too strong. I don't think it's good to stop it. I don't think it's good to slow it down. Probably we need just to surf it. To surf it, we need to understand technological progress then is not only about hard technology, tangible products, but it's also about the innovation in the process innovation. So having this balanced mix of technical and business innovation. Indeed, if you look at the recent history, and now I'm going to show you briefly two case studies, something very, very interesting happened in the last 10 years in the innovation for what concerns software. More than one thing. We will see some. So what is the innovation right now, and what are the role models in the business that we can look at? A question that I was asking myself more than once, it's about Uber. Uber is very interesting because they started their business in a kind of legally gray area. Okay, it was not clear. I mean, that area was not regulated. Now, you are not a taxi, you are something else, you are a citizen. In some countries and in some city, this caused many problems to the point that Uber was banned at the level of some cities. I don't know if it's still the case, but some time ago, in London, it was not possible to use Uber. I don't know exactly about London specifically, but definitely there was major conflict between the figure, the persona of a taxi driver and the Uber driver. But so apart from acting and moving and doing this leverage in this legally gray area, what Uber did right, many things actually. But then you can ask, is Uber a taxi or an IT company? Well, and what about Airbnb? There are similar ideas. These aggregators, these kind of social applications, they don't own the much of, let's say, of the tangible asset. No, they have this intangible asset, to the point that basically Airbnb is not a realtor, is an IT company, and the same you can say for Uber. Uber, well, is not a taxi company, definitely. It's an IT company. If you push this process further, you will see that there is a trend. Other example could be made, but it's very difficult now, or soon it will be very difficult to identify the difference between what is an IT company and what is another kind of company, because these borders of where IT ends and something else start are becoming blurred. Okay, there is no, and there will be no such a neat separation between this kind of business and another business. This is something that 15 years ago was not there. I mean, 15 years ago, you could understand clearly that Microsoft or Google or Yandex were IT companies, and there were other kind of companies. In the industrial revolution, in the fourth industrial revolution, as we want to call it, we will see that this is becoming more and more difficult to identify. So this is why you have to look also at this business innovation. Another notable difference of the way of doing software now with respect to 15, 20, 30, or 40 years ago is the concept of release. And here is where we will introduce slowly the idea of DevOps. Release, when I was a kid or a teenager, it was pretty simple to understand what a release was. If you wanted to get Windows 95 or Windows Vista, probably one of the worst Windows ever, it was pretty simple. You want to buy the new video game, you go to the shop, you buy it. And then you get a box, very nice package. There is a physical support. It can be a floppy disk, it can be a CD, it can be anything else, but that's the new release. And when you want the next release, again, you have to go again to the shop and take it. With the civil use of internet becoming widespread, this becoming a little bit more complicated. For example, take a Google, but you can do the same with Yandex. Okay, so the Google that you're using right now, what version it is, you can find it out. Definitely there is a way to find out what version of Google you're using, but it's not that obvious. And also, maybe it's not even that interesting. And when is the next release coming in? You may know, you may not know. It's becoming transparent. And this is a good process to some extent, that this is becoming transparent. Of course, there is a lot of folklore, a lot of emotions, a lot of very good emotions, very good things about going to the shop and buying a piece of software, no, in this physical device or in this physical support, the box. There is a lot of stuff. Also, the way in which the marketing is done has to change, because this transparency brings also new way to promote the software. But things are becoming definitely different. So if you look at this diagram, you can compare the traditional deployments that we can, until 2010, 15 was pretty common, no? In which you see that there is a release every some number of years, let's say 3, 5, it can be even less. And basically, there is no final product right now for all of the internet products, because there is just a permanent evolution. And this model is not only for software. This model applies to most of the intangible human artifacts. Another example, music. Think about it, the emotion of buying the last vinyl disc in 1983 or the tape in 1989 or the CD in near 2000 or whatever you go to buy in the shop, the new CD of your best artist with good packaging and so on. And this artist would release the new music, the new album every 1, 2, 3 years, depending. And now there is no need for that because you can just put the new song on the internet. You don't need to pack 10 songs somewhere to have 10 or 20 or 30 new songs to choose with. You can just publish one by one. It's the same concept. And this concept is moving slowly to basically any human artifact, creative artifact. I talk very often, I don't talk so often with musicians, but I talk often with authors, book authors. And apart from those that are maybe more junior and they need to publish the physical books or books with reputable editors to get some kind of visibility, the most senior authors, not only in computer science, in economy, and in probably in every discipline, some of them, they really don't care about publishing the next physical book or even the next ebook or the next digital book, because they can use a blog or they can use anything else where basically the new book is not a final product, but is a permanent evolution. They can just post it on the internet, changing every day. And the old concept of errata corrige doesn't need to be there anymore, no? Because you don't need to print a page with all the mistakes of the previous version. You just fix the version. And this is extremely effective. I mean, it can apply to every intellectual human artifact, music, arts, and writing, literature, and also to science, and especially to the science that we write, to the publications. This could be done the same. There are some obstacles to pass. For example, typically junior people, they need to get some reputation before being able to do that. So it's not for everyone, but in general, we are going into this permanent evolution. There is no final product. There is always something in constant evolution. So if you think about the example that I've made about the music, about the literature, about the software, it's all about the deployment, because it's about deploying the software or even the music or the literature. When I was a student, and I think probably not only me, and not only as a student, even later, there was this kind of feeling that once the code is complete, the job is done. Okay, there is testing, there is maintenance, and somewhere there is also deployment. But deployment, it was maybe not so often put the sufficient attention to the deployment, or maintenance. It's finished, someone will do. So we see the software development as composed of many steps, but the main steps typically are requirements, design, implementation, test. Then the code is completed after test. So that's it. The agile methodologies, they are focusing on getting the code complete earlier. Okay, so in case of volatile requirements, instead of producing hundreds of pages of documentation of requirements of design and not a single line of code, for example, if the project is interrupted or bankrupted, well, okay, you produce the features earlier, maybe on a bi-monthly basis, but still you focus on the code. Maybe even more, you focus on the code, on the completion of the code. But from the completion of the code to deployment, there is still quite a large gap. Code complete does not mean that the code is already in production, because in the middle, there is a deployment. And there are concerns about deployment. Some time ago, maybe a couple of years ago, I had an interesting conversation with a guy literally from UBS, the bank. We were exactly talking about this, and the conversation was very revealing, because he was not at all concerned about developing the software, but he was concerned about deploying. He said, okay, we develop software for the cash machine, for the ATM machine. We can easily delegate the software to some Indian company, or in particular, they were working with Philippines, I think. This is not a big deal. The problem starts when we have to deploy it in the physical devices. You can imagine that these physical devices are spread over all the country, for example. Okay, he was responsible only for some cities, but for him, the problem was the deployment. So typically, this is something that I don't teach or we don't teach to our students. We teach about the code, how to produce the good code, the quality code, definitely. And then we kind of forget the last phase, that is the deployment. But here is where kind of deployment point is where the DevOps philosophy is coming. DevOps is about eliminating barriers. So to reduce the time to market, keeping the quality, less errors, speeding up the handling of the incident, of the problems after the deployment, and in general, speeding up the deployment. So you see that the focus here is now moving very much from production of code to the deployment of the code. The DevOps as a list, the DevOps concept as a list 2 or 3, if you want, major pillars, founding pillars. There is something about the process. There is something about the tool, the technology, definitely supporting the process. But there is also something a bit neglected, but important, about the culture and the environment. You can say the same for Agile. Agile is mostly a cultural movement, but then, of course, it affects the process in which the software is developed. You know, we have a lot of Agile methods, and they are different, but they share some culture and environment that is in the Agile manifest. And then definitely there are tools and technology. The idea of DevOps, that initially when Patrick Debow, this Belgian engineer, came out with this idea, initially it was called Mobile Agile Infrastructure. Okay, this was the first name of DevOps that came, the name changed a little bit later. This name, this idea, this concept with the name Agile Infrastructure appeared around the year 2007. So Debois was frustrated by the friction that typically he saw between the developers and the operation teams. So try to eliminate this barrier, doing this with a different process, but also different philosophy. This frustration of different units in a company that are supposed to work on the same product, so therefore they should share the same objective, but sometimes they have different KPI, different conflict of interest, they have different focus, however, they should have everything aligned. It is not. It's a well-known situation in software company. I think basically, I suppose, literally everyone experienced this at least once. And this was an attempt of trying to move this forward. And now I want to get to my point. I told you basically how the releases are changing, how this is affecting the deployment, to the point that some people got frustrated and therefore proposed something else. But what we are actually doing now? So what is our project? That it's kind of in the early stages, I suppose. This is why I'm trying to involve people. So we understand the DevOps environment. We understand the background, why this DevOps philosophy came out, what were the need. We want to operate the anomaly detection. It's a process mining, basically to analyze the process, the DevOps process, identify the anomaly, and now I'm going to tell you what kind of anomaly where, but basically anomaly in the releases, in the different releases. In this concept of continuous releases, we can identify some anomalies from one release to the other. What this kind of anomalies can tell us, what they can teach us about the status of the project, and maybe later even about the style, the programming style, the habits of the developers. To do this, we have a tool that is machine learning that is became very popular in the last 10, 15 years, to the point that often when we refer to artificial intelligence, we mean machine learning, no? Neglecting a lot of other things. But yeah, this is the buzzword, but it's not just a buzzword, it's a set of very effective algorithms. Just to make an example, this should sound pretty obvious to many, but what is anomaly detection? And then I will tell you how we apply anomaly detection to the release to identify what. Well, for example, in my experience, my credit card was blocked many times. this never happened in Russia, but happened several times in the UK. For example, when I was years ago, maybe 10 years ago, I was not using the credit card very often. Maybe I was using this a few times per week. And then maybe there were days in which, for some reason, I was paying most of the things by card for convenience. And I had this card blocked several times because clearly the bank is searching for anomalies, so for patterns of behavior in your spending activities that are unusual. Okay, this is the outliers. This is exactly the same concept. We can utilize kind of same algorithm to identify differences between one release and the other. But what kind of metrics? Now we will see that actually if you want to identify anomalies, you need to say exactly what you are measuring. Okay. In the case of the bank account, you're probably measuring the spending, the amount of the operation, the place of the operation, and probably also the distance between different operations. These are kind of metrics that you can apply. For software releases, clearly, in these continuous releases, you need to measure something else. And I'm going to soon tell you what kind of metrics we want to use. And we already started using some of them. So DevOps is our context. We want to make simpler the interaction between the IT operation and the development. This DevOps, this is where it's coming from. And the DevOps have a tool chain, on a series of different tools that support the development from the beginning to the end in this continuous delivery, continuous deployment. And you imagine that all these tools, we will see some of them, all the time, they generate incredible amount of data all along the tool chain. So now this is an incredible, powerful machine to generate data. And as I was telling at the beginning, differently from 20 years ago, now we have the possibility to analyze this data in kind of efficient ways, depending, of course, on the computational resources, but we can do that. So if you identify the right metrics, we may also identify the risk of a potential failure in the future release. Just a very simple example. Let's consider line of code. It's a very simplistic. I mean, in the end, this by itself may not tell you much or may not tell you enough. But consider that we are in this continuous delivery environment, and basically we release more than once per day, or maybe we release once per day. And typically the release is an incremental process where maybe there is a modest amount of line of codes that are added over one day. And if you can identify a pattern over time, then what happens if one day there is a release with an enormous amount of lines of code, enormous, of course, with respect to what you used to do? It's very similar to the idea of the bank account. If I withdraw from cash machine, ATM machine every week 300 euros, one week I withdraw 20,000 euros, it's definitely strange. Of course, it can be justified. So we are not searching here for something that is completely automatic. I mean, even in the bank example, your card would be blocked, but you can relatively easily unlock it calling the bank. If I have to share my experience, for example, I had also experience of card block with Sberbank or in UK with Barclays, and with Barclays that's definitely easier. But yeah, this is a process that can be improved. In general, it shouldn't be something that is too difficult. Here, what we are proposing is a tool that is flagging releases, not that the release is kind of blocked automatically, but it would raise a flag for the development team. I will show you the process flow in a few minutes. But this is the idea, to put together algorithms and people. So I can tell you something like, okay, there were more failures in stages or more line of code in this release than usual. Is it okay? Think about it. So what we are doing here is a kind of process mine. Now we are analyzing the process and the data of the tool chain in order to get useful information for process management. So we identify trends and patterns that are in the event logs of the toolchain to see if something strange is there or not, and if or not should be signaled to the development team. And ultimately, the decision is obviously taken by the human. It cannot be elsewhere. We have so this large quantity of generated data. Can we manage them? What we can do? Okay, what we can do with it? And these are kind of comics that you may know from Dilbert, and I use this as in the middle of my presentation. We are completing the first part. We are going into the second part. So I take this as a kind of quick break, where you can maybe think. If you have question, you can ask now, you can ask at the end. Otherwise, we will move on. No, but kind of 1 minute break between the two parts, also to refresh a little bit your mind. When you deliver a lot of information, sometimes you need a buffer to synchronize. What's the latest on the software release date? We are right on time for the pre-alpha launch, unless we run into something unexpected. How often does that happen? Whenever I need it. So unexpected things happen. Definitely happen. So if there is no question at the moment, I would continue, and then of course we have time at the end. Anomaly detection has been extensively studied in literature. You can find entire books. And actually, the first thing that we did in this project is, of course, taking the literature, taking the books and reading, especially with my data science colleagues. The outliers, more in general called anomalies in non-technical language, are variation from the expected norms, from expected template of behavior. Anything else is an inlier. So there is inliers and outliers, sometimes called anomalies or non-anomalies. We can determine the outliers basically in two ways: manually, automatically, or a combination of both. So we have machine learning algorithms that can do that. Literature is full of this. Or expert knowledge, something that can be analyzed one by one. Maybe it could also use to the combination of two would imply that the expert is labeling and the machine learning is doing the supervised job. It depends. So we are trying to understand what is better. Here we are not considering supervised learning, but this is something that can definitely be done and should be done. So to summarize, modern software development may come and generally come with continuous releases. This is the idea of DevOps, but even if your company doesn't fully implement the DevOps principle, the same way as probably doesn't fully implement the Agile principle, modern software developments, it's going in this direction. So there are many elements of Agile and DevOps that are there, even if you don't follow everything by the book. Some of these releases that are coming every day or multiple times per day may have variation from the expected pattern, the same way in which the bank transaction can do, as I mentioned before. So some of the release may represent outliers. If you are able to spot these outliers and flag them, we can definitely help developers in paying more attention on that release and maybe do further testing, or maybe not. So this is what we want to propose, a support for the developers. And I was telling you at the beginning, I will repeat at the end, that we can know developers better than them. I mean that in a small team, we are able here to identify through some metrics, some behavioral patterns of the team, maybe also of the individual developer, and tell them, look, you are doing something that you typically don't do. And this is something that the developer themselves may not be able to do, because we know them, or the algorithms know them better than themselves. You know the idea of cowboy coding, no? This is an idea that is very popular or negatively popular in the agile communities. No, they don't consider this a good practice. I don't always test my code, but when I do, I'll do this in production. Okay, this is definitely how I started coding. I mean, I think probably all of us started kind of cowboy things. first programs, even probably the first programs that you did for money. Definitely the case for me when I was a student at the school and I was writing C programs, interfacing with SQL for helping the nearby shop to use the database and to record some. So I remember one example, for example, of the CD rental. I mean, to the shop that was renting CD. So this one of my first project when I was probably 16 or something like this. Yeah, so we all started there, no? But you understand when you develop critical software or you develop bigger software in a team, not only one person, this is absolutely not, not a decent practice. So what you do in DevOps typically is to have 3 stages. They're called development environments. There is the development stage, the staging, okay, let's call environment, the development environment, the staging environment, and the production environment. Staging environment is an environment where you duplicate all the conditions of the production environment, settings, software, hardware, but it's not the production environment. So you are not in production yet. So you can do any evaluation, any test before actually putting the code into production. This is one of the ways to avoid this cowboy coding. Not the only way, but it's one way, of course. There are other practices that one should adopt. So if we look at this staging environment, now we should easily understand that this is the place where we should also do the anomaly detection, because that is the right place. So our idea is, in order to reduce the risk of problems in the production stage, we run an anomaly detection system in the staging environment so that we can, in this phase, in this safe environment, compare a release with the previous ones. And we are not yet in production, so we can identify some extra problems. So it's not about testing. The release has been already tested before. Anomaly detection is a further step of verification or of validation, if you want. I will not go into the details of the difference between these two things. So we identify the following flow. If our algorithm, and I will tell you more about the algorithm a little bit later in this second part of the talk, if the algorithm is not identifying anomalies, well, we consider, at least now it's experimental, we have a proof of concept, but we consider that there are low risk in going into production with this release, if everything works fine. So we say there is a low risk, there is a high risk. If we identify a low risk, no problem. The new version of the software can be automatically released in production. If anomalies are somehow detected, we should suspend the release. We cannot proceed with this automatic release in the production, but we should call for the attention of the team. So we should alert that more study, more analysis, more verification should be done in the stage environment for what concerns that specific release and potential anomalies that is identified. So simplifying, in our article, we published some articles about this project. In one of the articles, you will be able to see this kind of picture. So we can maybe spend 1 minute on this picture. It's very simple, it's a bit abstract, but it should mitigate every doubt about how the process is supposed to work. Now I told you where it works. It works in the staging environment. Now I'm going to tell you how the concrete flow works. So at some point you came to the day of release or the hour of release, depends how often you want to do the release. You had a period of development that can go from a few hours, in some cases literally a few hours, to a few days. Typically, maybe a few weeks, but typically the environment that we are looking at, it's much more, there are way more frequent releases. So you have a period of development and testing, and then the moment, better to say the moment of the release more than the day of the release comes. So we identified metrics. I'm going to talk about it soon. Metrics to analyze. So these latest metrics are collected. Our anomaly detection is executed. The simple case is where there is no anomaly detected, automatic release. The more complicated case, or maybe more concerning case, is where the anomalies are detected. In that case, the team is alerted. So look, there may be a problem. I mean, we don't know for sure there is a problem. There may be. So you need manual inspection. And if there are no real problems, at that point, the manual release will be required. And if there are problems instead, of course, the release should be analyzed better and fixed. And then you can restart from the beginning. This is a very simple flow. I mean, we are not proposing anything interesting. I think the innovation of our work is in the combination of these two different things, DevOps and anomaly detection, that at least at the moment in which we started the research, we didn't find much because of course, we analyzed the literature. Maybe at some point in parallel with us, other research team may have started similar work, and this would be great because probably we can cooperate. The machine learning will help us to do human-made assisted decision. So the system improve over the time, but still the human presence, the human inspection, it's required later. Obviously, the alternative that I presented before, where I say, okay, an expert can analyze the data, it's feasible only if there is a small quantity of data. When we have DevOps toolchain, the pipeline is generating so much data that manual inspection becomes virtually impossible. And maybe I can remove the word virtually. So this amount of data from the DevOps toolchain is generated from all the tools. There are logs, metrics, and so on. So let's see how automatically we can extract and analyze this data, and what data in particular, because the first thing that one should do is to see, okay, we cannot analyze all this data anyway. What kind of data do we want? And here is where my colleagues that are more expert than me in the machine learning stepped in, helped me to study the literature about anomaly detection. And you understand that anomaly detection is typically done on unsupervised machine learning that can be used to flag outliers in a data set that is not labeled because you don't want or you don't have the time or it's not feasible to have the labeling in advance. We are trying to put together this understanding of DevOps, process mining, anomaly detection, and machine learning in practice to put together the software engineering, but in particular the agile philosophy and the DevOps philosophy, and the data science. So to put together people that have understanding of the problems on the two sides, that like in the DevOps, the operation and the development try to talk together, here we are trying to do the same, okay? And I think that in this specific field, we started first. There may be people joining now the same research. It's good to push this study because it's extremely interesting. And we found out already something. I mean, we are at very first stage of the study, but we did something, and now I'm going to show you what we did. And if there is any advice, any interest in cooperating, I'm very open. So what we did initially, okay, we searched for projects, for a project that we could use to analyze the data, but a number of problems appeared. You know, we contacted several companies. Can we access your data? Yes, no. Even when they were positive about all the confidentiality and so on, it was not easy really concretely to utilize the data. So, and there was also some skepticism. So we said, how can we break this skepticism at the moment? So we will never be able, we are in a loop. We will never be able to break the skepticism if first we don't show something that works. No? So we say, okay, so let's do a kind of relatively little proof of concept that works. And then the next step that we are trying to do right now is to show them that this stuff is working in our proof of concept. And then maybe they will let us access their data. Because we were in a loop, we really tried for a relatively long time, weeks, if not months, to get access to real project. And we were always there, but with this kind of skepticality, you know, hesitancy. So we needed a development process. So we created one. Actually, in particular, one of my students created a relatively simple project that was a platform for displaying information and images about space mission. So something funny, something fun, that it was fun to do and is also fun to use. Setting up a toolchain, a DevOps toolchain, and utilizing the anomaly detection algorithm. So we call this algorithm the Space Viewer Anomaly Detection System, SVADS. On this we use it on this relatively simple platform that it was used to show this NASA pictures that are available online because there is an API. Okay, something simple, something catchy, something that the student had fun on, and something that also it's cool to present to companies, to collaborators, to other research group to show the effectiveness of the tool. So we set up the toolchain, GitHub, Jenkins, all the classic things. And then we identified in the literature one and more algorithm, for example, LOF, that are suitable for the anomaly detection. So we used Python, we used the library that Python is offering for this kind of machine learning algorithm. And we used the idea of DSP, as mentioned before, that we operate the anomalies detection in the staging environment. So we are putting together all these ideas that I just show you during this presentation. Another key point was missing. So the metrics. So what we are going to measure in the case of bank transaction, I mentioned the amount, the timing, the zone. For example, if you buy at 11 a.m. A flight ticket, a plane ticket in Moscow, and after 1 hour you buy a cafe in New York, well, obviously there are some concerns, no? Because also the geolocation here says that something unusual is happening. How did you manage to move, or your card to move from Moscow to New York in 1 hour? So all these kind of things are taken into account. So here we are trying to identify some metrics that can be useful to be extracted from this DevOps toolchain. And these metrics are stored, are logged, are recorded by the different tools that you have in the toolchain. So all these metrics are available for analysis. Lines of code is the most obvious. It's always the most obvious metrics. Anything you want to do, I mean, in software engineering, you think about do something about line of metrics, even wrongly, of course. Developers' productivity was measured by some people at some point in lines of code. So this is a very simple metric that you can use in many different wrong ways. And it's very difficult to use it in a right way. In some sense, maybe, I think that anomaly detection may be one of those cases in which line of code can be more meaningful than in other cases. Because literally, when you have this incremental release of functionalities, typically there is a kind of consistency in the number of lines of code, but it depends. So of course, this has to be assisted by the human. Failed bugs in the staging environment, failed builds. This is also strange. I mean, if there is larger number of fail than normal, well, so it can say something. The failed automatic tests, the failed deliveries, if the number of issues in GitHub shows some anomalies, or the issues that are signaled by the code climate. So statistical models can help with these metrics to identify potential risks in the release. So something that may be wrong in that release. So if you look at this picture, is showing, taken from the paper, is showing exactly a more detailed flow. I showed you before the flow of things should work. It's more detailed because you see in the DSP model and in the tool chain where things are happening. So what we did, we developed these space viewers. This took a few weeks. Definitely, it's not a very large project. And then we needed to do a preparation where we collected the data to establish a baseline. Because how do we identify an anomaly if we don't have kind of initial set of data to compare with? So basically, these 25 releases in production that we did for the experiment, the first 10 releases collected metrics, but we didn't do the anomaly detection. We started from number 11, using the first 10 release as a kind of baseline. And you see how it works now that in the staging environment here, you have the SWATs, the anomaly detection, operating at this stage. And then, depending on the result, you may need to go back to the development environment, or you go to the production environment. What did we get? So we applied some algorithm. First of all, we applied the local outlier factor. That is an unsupervised anomaly detection method that has been growing popularity in the last 20 years. We know that data is not labeled. We don't want to do that. No, we don't have, and we don't want a specialist that at the beginning of the project, at the beginning of each release, would do this labeling. Also, imagine that is costly in terms of time. Here, everything is happening very fast. So everything has to be automated and supervised in the sense that the results of the algorithm have to be checked relatively quickly by the human. Okay. Imagine that if you have several releases per day, I mean, this is the only way of doing things. With the LOF, what did we get here, for example? So these are the 25 releases. No? You see that there are some releases like 15, 18, 22, and 24 that show something strange. Here we are showing, this is a very simplified diagram in which we show the line of code that are committed here and the number of tests failed. Only 2 dimensions. Okay, here we are seeing only 2 metrics to have an easy visualization. Okay, of course, doing the analysis with more metrics, it's way more informative. We didn't do it yet, but doing the analysis on more dimension, it's more informative, but it's also more difficult to visualize. In 2 dimensions, we see effectively the proof of concept. So something stranger here, So you see, 24, it's something strange. So maybe there is an anomaly in these releases. To have a confirmation, we validated the results using overall 4 different anomaly detection techniques that we took from the literature. So algorithms that are typically used for this kind of things. And if you look at the diagram, well, basically there is a kind of very, very general agreement. There is, for example, one release number 18 that you see number 18 is here, 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 and here, that in some cases, in the case of robust covariance and isolation forest, gives a slightly different result. And now what we have to do is to check better why there are these differences. But overall, basically, the results that we are getting are the same. So I'm not saying that you should run 4 different algorithms every time you do a release. But with this diagram, with this experiment, I'm telling you that probably any algorithm that you take, for example, LOF, is giving kind of result that would be consistent with other algorithms too. So probably you can run only one. And then what the team would do, okay, what's happening with this release 24? What's happening with this release 22, 15? No, there is a need for manual inspection here. Obviously, we worked on a proof of concept with a small data set. So the next step, among many steps that we have to do, the next step is to operate on a larger data set. And this is what we are trying to do. Now with this proof of concept, we are discussing with companies here in Innopolis, but we would be happy also to discuss with others to show if finally there is less hesitancy, less reluctancy in getting us accessing the data, and see if this kind of experiment can be, the results of this experiment can be confirmed with a larger data set, maybe more realistic in a productive environment. Some comments. Now I'm going into the final phase of the presentation, and I'm wrapping up in a few minutes. Then we can start the discussion. Some comments on the proof of concept. So here you see that we don't need to set a fixed thresholds for the anomaly, because these thresholds are generated by the algorithm looking at the previous data. What is, I think at this point, it should be absolutely clear, but if it's not, I will emphasize it more, that this analysis is not 100% accurate. There will be a number of false positives and negatives. We still don't know what the percentage of these false positive or negatives will be in the total. My expectation, but this is just a feeling, I mean, it's not based on any strong result or any strong evidence, it's just my feeling from the preliminary results, is that it shouldn't be much. I have the impression that it can be relatively accurate. Of course, always needing human supervision. So before releasing in the production stage, in the production environment, should be checked by the team. So we have seen how we set a direction of research, I think a new direction of research, of the use of machine learning to support the DevOps automation and the continuous releases. We try to see how this process, how this anomaly detection can have an impact on the releases. Considering, again, I repeated this several times, but I think it's always important to remark that decisions are assisted, but not human-made. We cannot do that. I don't think we can really reach that level. And now the next step, what we are trying to do now, is to getting more confidence about our results, showing more experimental evidence, of course, using a larger data set in a larger project. Well, to summarize, just give me a last couple of minutes to complete the speech. Now I'm gonna go, I went from the general, no, at the beginning, we started from some very general consideration about our time, and then we narrowed down to a very specific project. And then I showed you some details on the project, and now we plan to continue this project. But now in the last couple of minutes, I want again to make it broader again, because what we see from this research and from much other research that's going on is that this time that we are living is very, very interesting. So it seems that somehow, finally, we, computer scientists, but especially with the expertise of data scientists, we can kind of hack the world. We have the ability to store and analyze an amount of data at a speed, depending, of course, on the computing power, but this is unprecedented in human history. If we have the domain knowledge, in this case, for example, DevOps and the tool chain, we have this domain knowledge, we have the computational resources, we have access to data, we have a very strong forecasting power. So the system, in this case, the system of the anomaly detection, knows the developer team activities better than the developers themselves. So can tell you, look, something strange is happening with you. So if you generalize this, basically you can predict even the actions of the developers or of the user in general. So the last question for today, so the last slides that I'm gonna show you before the discussion, and then I hope that we can also, after some needed clarification, we can also discuss a little bit about this, because I think it's very interesting. Can we use this to help developers to understand their mistakes? So is there kind of the dream is to have an educational value here, is to give the possibility to developers from the anomaly detection, not only to just to fix the release, but also to understand their development, their working patterns, their classic mistakes, their typical mistakes. And maybe this tool, together with an anomaly detection, could also be an instrument for continuous learning of developers. But this is an open question, because at the moment we didn't think about it. I didn't discuss this question with my team, actually something that I just added without discussion. But I see also the potential for an educational meaning of this kind of systems. So I think I will stop here. I'm open for questions. I'm open for debate, for discussion. Probably we have about 10-15 minutes for that. And so I will probably mute myself and wait for your intervention.
Yes, Manuel, thank you very much for the nice talk. Now we indeed have some time for questions. So if you have a question, feel free to ask or write to the chat or yeah.
Or alternatively, you can answer my question. If you don't have a question yourself, you maybe have an answer.
Yeah, so far I have one question. So, for example, did you consider, I don't know, using some GitHub repositories because you can probably track their commits, which is some sort of releases or something like this? So can you parse GitHub to have a collected database for your research?
So we can, is something that potentially we can do, and is one of the next steps. Also, if you see here, basically I mentioned that one of the metrics, that the valid metrics to use is absolutely using GitHub to do this kind of analysis. We didn't do it yet because you see, for now we focused, if you see the experiment, we focused on number of tests and quantity of committed line of code, because this is what we did as a proof of concept. But definitely GitHub is a must. There you can find out many, many interesting things. So yes, we need to develop in that direction too.
Thank you. And also another question, who would you say is the target audience for these things? Because probably big companies, they already have some good quality control. I'm not sure. Yeah, this is my impression. Yeah, so maybe this is targeted for smaller companies, something like that.
I think this is targeted. I'm not saying that big companies cannot have any use here, but this is targeted to mid-sized company. So if the company is very small, maybe a few people and working on relatively small project, they may not have the need maybe to invest time. This is not a commercial product, but they may not need the time, money, or interest to go into this, and the benefits may be very, very, very limited. But when the company is not too big, but not too small, mid-size, 10 to 50. And companies like this, they are already coping with kind of largish project. And some of them, they are indulging, or maybe if it's not a company, it's a specific, relatively small team in a larger companies. For example, in the past, I worked and collaborated with companies like Bosch and Siemens. They are very huge. But some of their teams that are working on critical or maybe mission critical or maybe sensitive or financially critical or life critical, safety critical systems, they tend to do more than what other teams in the same company do. So they tend, for example, to use specific tools for doing further checks. Can be model checking, can be requirements formalized in a specific manner, can be specification languages based on mathematical language. So they do more. They do more because their work is more sensitive to safety. This is why I think this kind of companies or this kind of team that are relatively small, even in bigger companies, because bigger companies are done of small teams. And some of these teams are acting in a kind of autonomous manner, in the sense that they may use different tools from each other. They may need different level of quality check. So when there is kind of that size, mid-size, I think it is worth adding some kind of extra check like the anomaly detection. For the small company, not. For the very large group, probably you are right that they are very well organized, but there are companies that have teams inside them that they are always searching for new solutions. I remember working with Bosch some years ago, in which through consultancy, we managed to convince them to use some verification tools that initially they didn't think of. And it was a relatively small team in a large company. So large company can also have space for this kind of experimentation.
I see. Yeah, thank you.
Maybe anyone want to say something about my question? What do you think about it?
Yeah, so far there is one more question
okay,
from the audience, from Maxim Karpov, please.
Yes, hi, Manuel. Thank you for your presentation. I have actually two questions. The first one, could you please clarify, maybe I missed it, You are solving the anomaly detection tasks on a running case in logs, so you want to predict when the future anomaly will happen. So it's something like predictive maintenance tasks, or you are solving the anomaly detection tasks as is. So there is historical data and you're trying to find these anomalies.
At the moment, what we are doing is to detect the anomalies in the very moment in which the team want to make the release. Okay, so it's a kind of runtime. It's happening at runtime. So this is what we are trying to do right now, because we think that it's basically it's what you call it's preventive maintenance. So we are trying to do this on the go, because we want, this is a classic thing in software engineering, is when you want to fix the problem as early as possible, because the earlier you fix them, the cheaper it is. So if you do multiple releases every day or one release every day, and you can identify as many problems as possible in that moment, that would result probably in a much more convenient, much more more satisfaction from the user. Okay, because you check it things before going into the production. So you see that, yeah, I think we are exactly doing predictive maintenance. What we are doing here is before the production, in the staging phase, trying to find out the issues, as many issues as possible. Of course, in the staging phase, you also do normal testing. You can do the interesting thing about this process is that is not preventing you to do any other kind of analysis. You can apply any other techniques of verification that you are already applying maybe in the staging phase. You just add one step to the verification.
Okay, thank you very much. And the second question was about process mining. You've mentioned that you are trying to combine these approaches with machine learning. Can you please tell a few words about it?
I mentioned process mining, and this is kind of the weakest part of the talk, because I mentioned it kind of the go briefly, because there is much more that we can do than what we do now. So process mining means basically being able to analyze a process in order to improve the process itself. Then, of course, if you improve the process, very likely you also improve the product. I was mentioning this process mining thing a little bit superficially, and I didn't go deeper exactly because at the moment, we don't know exactly how to go deeper. So when I say process mining, I mean some elements that you see in literature about process mining. Now we are applying to the DevOps process. So there is a tool chain, there is a very specific process, the data is collected at every step. So we are trying to do some analysis, which is the anomaly detection on this data. And this work goes into the very broad context of process mining. But the part of the talk about process mining, it's a bit speculative, because I'm saying, yes, this is process mining to some extent. But this is you identified exactly the weak ring in the in the chain, because there is much more that we need to understand there to say we are doing process mining. Very general terms, we are doing process mining, but it's not exactly what we didn't go very deep into this.
Okay, I got it. Thank you very much.